Okay, so you've got your tank with the water, one floated on top, one floated but not on top. It sort of was suspended there, and then one sank, right?
Yeah.
And then we used Isaac's and Isaac and Eli's as our examples. Now, what was the mass of the one that was the floater? Someone tell me. Look back at your notes. Eli, what was the mass of the one that was a floater?
The 6.6.
6.6 grams.
No, it's 10.6.
Oh, so double check yours. Make sure you got the right thing. 10.6 grams. And what was the mass of the one that floated but not on top?
That's suspended. 48.4.
48.4 grams. Now, as these people tell me what the mass was, double check it against yours. Make sure that they're telling me the right thing. And the one that sank, what was the mass of it, Marissa? 120.2 grams. Now, what we're going to do is find the density of these three, because one of the things that we've learned already is that density can affect whether or not something floats or sinks. And remember we had clay before, and we messed around with our clay and we got it to float. What did we do to our clay to get it to float? Jacob.
We changed its shape.
We changed its shape. What else did we change about it when we changed its shape? The shape wasn't necessarily what made it float, though, Anshul. We changed its volume, and when we changed its volume, it made what change? Density, because remember, density is mass divided by volume. So if you change that volume, when you do that math problem, you're going to get a different answer now. So we want to calculate the density of these three, and we're going to need the volume. And I told you that line group had already done this the other day. So instead of putting it back down in a graduated cylinder with water, we don't need to repeat that. We'll just use theirs because it's the same canister. What was the volume? I know, remember, I'm catching my notes up with yours. We've already done that's what I said at the beginning. What was the volume, Caden?
58 cubic centimeters.
Yes, thank you. Remember I said at the beginning, I lost my notes when my computer restarted this morning. And that's the same for all three. Who recalls why we said we don't need to do it for all three? Does anybody remember why don't we need to do this for all three of them? Ian?
Because it's all the same.
Yes. And if we had done it in here, like line group did, which one should we have used when we found the volume? Macy?
The one that sinks.
Yes. Why should we use the one that sinks, Macy?
Because on the other ones you would have to push it down.
Yes, we wouldn't know the full volume if the whole thing's not submerged in water. So now we're going to use that formula. What's the trick? Have you remembered the formula for density? Density equals love. And so that means what divided by what? Mass divided by volume. So we're going to put D equals M divided by V underneath each. And then we'll plug those numbers in there. And I'm going to have to squeeze mine in. And remember, you're going to write what I write. So in this one, the mass is 10.6 grams. And the volume is 58 cubic centimeters. And I'm going to give someone a calculator and have them do the math for us. Madeline, do that first one. 10.6 divided by 58, Madeline. Tell us what number you get. 10.6 divided by 58. Okay, so keep that up. I'm going to pull up my calculator, so we'll have more than one. So 10.6 divided by 58, and see if I get, yep, I got the same thing. Let's round this to the hundredths place. So it's going to be 0 and 1800ths because this is a 2. So that 8 is going to stay the same. So the density, and I'm going to squeeze mine in here, hopefully yours is better than mine, is 0 and 1800ths. And remember the units, we're going to use both of these. Grams per what? Cubic centimeter. Nice. Okay, Madeline, take that calculator to someone else. Just pick any one you want. We're going to do the one that suspends. So Cole, if you'll do that for us, and I'll come over here and write it down. Density equals mass divided by volume. The mass is 48.4 grams divided by 58 cubic centimeters. And Cole, if you'll tell me what you get. 48.4 divided by 58, Cole. 0. What? 0.8. Now I'm going to do it too, Cole, and see if my matches yours. 48.4 divided by 58. Yeah, I got 0.834. Is that what you got? Okay, so we're rounding this to the nearest hundredths. Here's the hundredths place. Look to the right. That's 4 or less, so this 3 stays the same. So the density of the one that was just suspending there, didn't float on top, but it floated, is 0 and 83 hundredths of a gram per cubic centimeter. Cole, you choose someone to pass on to do the one that sank. He's giving it to Isaac, so I'm going to rewrite it under here. Make sure you're writing what I write. And I'll need someone with very nice handwriting for Reagan and Addison to copy. And this one, the mass is 120.2 grams. And volume, of course, still the same. So Isaac's going to divide 122 divided by 58. Tell us what you get, Isaac. 2.07. Let me see if I get the same thing as Isaac. 120.2 divided by 58. Yeah, 2.07. Isaac already rounded up to the nearest hundredths for us. So 2.07 grams per cubic centimeter. Now, I want you to notice something here. Signal me when you're completely caught up with me. So I really want everybody's eyes and brains to be on this. So this side's good, waiting on Will. Who's doing work for Addison today? You got it out? Who's doing work for Reagan? You got it out? We'll wait and see. Okay, now, here's what I want you to notice. I want you to compare these numbers here. Here's the density of the one that floated on top. It's 0 and 18 hundredths. The one that floated but not quite as high is 0 and 83 hundredths. And the one that sank was 2 and 7 hundredths. Talk to your neighbor for a second. Do you notice anything about these numbers? What's going on here? The one that floats on top, suspends, and then sinks to the bottom. Do you notice any pattern? Talk to your neighbor for a sec. Back with me. Does anybody notice anything about these numbers? The one that floats on top, then the one that suspends, and then the one that sank to the bottom. Avery, what did you notice?
It's increasing.
It is increasing. Notice that which one is the very least dense of the three? The floater, yes. Only 18 hundredths of a gram per cubic centimeter. And the one that's the densest is what?
The sinker.
The sinker. Now, we were talking the other day about, in order for something to float in that material, it's got to be less dense than it. We made that clay less dense when we increased the volume. Our clay's density went down, it was able to float. Before, what did your clay do?
It sank.
Yes, it sank. Board. So, yes, Avery, you're right. Avery's noticing that the ones that floated on top was the least. The one that sank to the bottom had the greatest density. And when we were messing with our clay the other day, we actually lowered its density and it floated. The other day when we first talked about density, I had you write something down in your notes. And it was at the very end. I said, make sure you remember this. I said, oh, it's a hard number. I was joking with you. Turn back to your first notes on density. It should be on the page where the golf ball and tennis ball are. I had you write down a fact. It was the density of a certain material. I said, just write this down. You're going to need it for later. Raise your hand when you think you found it. Aiden.
Water density equals 1 gram milk.
How do we say it? 1 gram per milliliter. Yes, so I had you write down the density of water because that's going to come up a lot in our experiments that we did this year. Water's density, is 1 gram per milliliter. Now, you don't have to write it in. You've already got it written down. Go back to this page. I wrote it up just for us. So for every milliliter of water you have, it's going to have a mass of 1 gram. But this is an important fact in this situation because I want you to notice, compare these numbers, these densities, to waters. Is this less than 1 or greater than 1? Less than 1. What about this one? Less than 1 or greater than 1? Less. What about this one? Less than 1 or greater. So now, see if you can figure out next, what do you think water's density has to do with something floating or sinking? What does its density have to be in order for it to float?
Less than 1.
Yes, it's got to be less than water's. Look, the ones that floated are less than 1. The one that sank is greater than 1. So things that float in water, their densities have to be less than 1. Things that sink in water, the densities, when we calculate it, it's going to be greater than 1. Now, I want you to look at this one for a second. Look at this one for a second. That number is less than 1. Say it again.
But it's real close.
It's really close to 1, isn't it?
That's why it didn't float.
Yeah, it floated, but it just didn't float on top, right? It's floating, but it didn't float on the very top. And one of the reasons is it's really close to water's density. It's almost the same. Now, I want you to apply this to another situation, the human body. If we were able to take the human body, a person, and put them, hold the breath, in a graduated cylinder, a giant graduated cylinder, what do you think the density of the human body would be close to? Which one of these do you think it would be closest to? The floater, the one that floats on top, the one that suspends, or the one that sinks to the bottom? Which one do you think is closest to what the human body does? Laura? So the human body sinks to the bottom?
No, actually, the 0.8.
Yeah, the one that suspends. Think about the times you've been in the pool now. As a former pool rat who would go to swim team practice in the morning, stay at the pool all day long, and go swim team practice at night, sometimes stay for a pool party. I can tell you, I know all about playing games in the pool all day long. One of the games that we used to play where we would actually try to see if we could sit on the bottom of the pool. Have you ever tried to do that? We would cross our legs. Yes, and in order to do that, if you just try to cross your legs and go down the bottom, what happens?
You float up.
Yeah, and it's usually, if you sit in, it's like this. And so we would do this to try and see how long we could stay down there. Because the human body will float. Now, if you've ever taken swimming lessons or had someone teach you how to swim, you know that, yes, the human body will float, but it doesn't float on top, does it? Have you ever tried to float on your back?
Yeah.
Yeah, there is a knack to it. You have to hold your body a certain way. You have to arch your back a little because you'll float, but your face will go under a little bit because your density is closer to this. It's close to 1, but not quite 1. So our body's density, if we calculated it, it would be close to 1 because we don't, we float, but we don't float on top. Stay with me. Okay? So, eyes. In order for something to float in water, it has to be less dense than water's density. Water's density is 1 gram per milliliter, so the density of that material has to be less than 1. Now, turn back to the golf ball and tennis ball. Which one floated in the water that day? Golf ball or the tennis ball?
Tennis ball.
The tennis ball did. Look again, what was the density of the tennis ball when we calculated it? We're raising our hands. What was the density? Not the mass and the volume, the density. When we did the math problem, is something grams per cubic centimeter. What was it, Macy?
0.47 grams.
0.47 grams. Is that less than 1? Yes, it is. And then, what did the golf ball do, boys and girls? What was its density? What was the golf ball's density? Something grams per cubic centimeter. Will?
1.125.
1 and 125 thousandths grams per cubic centimeter. Is that more than 1?
Yes.
Yes. So in order for something to float, it's got to be less dense than the material it's in. Now, before we go further with this, you need to know this later on, probably high school, when you're going to come back to this topic. And there is a little bit more to it than just density. There's also, you have to take into account how much water that object displaces. Okay, but for now, 5th grade, you know that it has to do with density. Now, let me stop right here, and we're going to shift gears.